Hey students, I want to give you a video about the 10D gas stoichiometry answers. And remember, when we do these gas stoichiometry problems, for this introduction to that, we are going to assume that every problem occurs at STP, standard temperature, 273 Kelvin, standard pressure, 1 atmosphere. Knowing also that our standard molar volume of gas at STP is 22.4 liters in a mole, and also knowing that we can always find the molar mass of any of these gases from the periodic table if we need to. So let's go through these. Number one, what volume will 0.750 moles of nitrogen gas occupy? So before I set up my table, I really like to get a mental outlook on what I need to do in these gas stoichiometry problems. And in this case, I know the moles, but I don't know the volume. So I'm going to have to make a calculation that converts moles to liters. And I can see that right now that if I have moles and it's at STP, I can look up here and there are 22.4 liters in 1 mole. So I write down what I start with in the problem, and I want moles to cancel. So that will go in the denominator, and there are 22.4 liters in 1 mole at STP. So 0.750 times 22.4 divided by 1 gives me a final answer of 16.8 liters of nitrogen gas. So pretty simple, one-stepper on the first one. Number two, what volume will 100 grams of oxygen gas occupy? So for this one, I start with grams, and I need to finish with a volume answer. So there's only one way to get to this. I can't directly convert from grams to liters, but I have to have something in the middle. And that something in the middle will be moles. I have to go grams to moles first. Once I get a moles answer, I can then convert that mole answer into a liter answer using 22.4. So the problem says I start with 100 grams of oxygen. Using the periodic table, the molar mass of oxygen is 16.00 plus 16.00. So that goes in the denominator, and that's per mole. That will give me a mole answer. I then use my standard molar volume of gas, knowing that there are 22.4 liters in 1 mole. And now I can punch this in. 100 divided by 32 times 22.4 gives me a final answer, 3 sig figs, of 70.0 liters of oxygen. Number three, how many moles are contained in 2.500 liters of methane? So I start with liters, and I want to convert that to moles. So this seems like a pretty simple problem using my standard molar volume. I start with 2.500 liters of methane, CH4, and then there are 22.4 liters in 1 mole. So I get liters to cancel. That's 2.500 divided by 22.4 gives me a final answer of 0.112 moles of methane. So like I said, pretty simple one on that one. Next, calculate the mass of 30 milliliters of dinitrogen monoxide. So this is going to be a big one, where I start with milliliters, but I have to finish with grams. So the first thing I have to do is convert from milliliters to liters. Once I get a liters, I can use my standard molar volume to go to moles, and then once I go to moles, I can use the periodic table to convert that to grams. So really a three-step calculation. Start with what I know, 30 milliliters of dinitrogen monoxide. And the first thing I want to do is divide by 1,000 because there are 1,000 milliliters in 1 liter. Now I have that in liters. I use my standard molar volume and divide by 22.4. That will give me a mole number. I can then go to the periodic table, and dinitrogen monoxide would be 14.01 plus 14.01 plus 16 to give me a molar mass of 44.02 grams. So punching this into the calculator, that's 30.0 divided by 1,000 divided by 22.4 times 44.02 to give me a final answer of 0.0590 grams of dinitrogen monoxide. And finally, number 5, I wanted to make you do a problem the exact opposite way. So starting with grams, but finishing with milliliters. So the first thing I have to do is kind of the way station for all of these is getting something to a mole number. Once I have moles, in this case, I can convert grams to moles using the periodic table. Once I have moles, I can use my standard molar volume to get that to liters, 22.4. And then I can use my old metric conversions to get that to milliliters. So writing down what I know, 10 grams of ammonia, NH3. Periodic table says that's 1 nitrogen plus 3 hydrogens. So 14.01 plus 1.01 plus 1.01 plus 1.01. Then that gets me to moles. I can use my standard molar volume of 22.4. That will give me an answer in liters, but I want an answer in milliliters, so I'll have to multiply by 1,000. So calculator use 10.0 divided by 17.04 times 22.4 times 1,000, sig figs matter, gives me a final answer of 1,310 milliliters of ammonia. That completes the answers to 10D gas stoichiometry. You will have some similar problems on the review and on our Unit 10 gas law tests. Good luck, and I will talk to you all later.